ওটা হচ্ছে I think dates are different. It's 3 and 4. যেটা হচ্ছে first day, that's most likely yours. I don't know if it's 3 or 3-4, but যেটা আগে হয় that's going to be yours. Okay, let's continue. So আমরা last class-এ ohmic conductor করছিলাম. If you guys have any question, do let me know. Very straightforward. Also, to be honest, আজকে যা করবো is also very straightforward. আচ্ছা, complicated জিনিস হচ্ছে just একটা topic আসবে called potential divider. ওইটা আমি তোমাদেরকে আগে থেকে বলে দিব. Potential divider, potentiometer, internal resistance. এই তিনটা জিনিস is like new, complicated না new. Okay? আজকে যেটা করাবো, it's exactly what I would teach you in O levels. So you'll find a lot of similarities with what we have done before. So today we'll see IV characteristics of 3 different components. So তোমাদের syllabus মধ্যে you need to know the IV characteristics of metal conductor, right, at constant temperature. What is the metal conductor at constant temperature going to obey? Ohm's law. So we're done with that, right? What is the graph supposed to be? A straight line passing to the origin, right? And that's about it. Now, if you don't maintain the temperature, what starts to happen? Yeah, the graph will start to change, right? So we made a very big assumption, and to be honest, it's not a justifiable assumption. আমরা কি assume করি that all the circuits that we have what temperature? Yeah, but that's far from reality. In fact, having a constant temperature circuit is the ultimate aim of everyone. It's not achievable, right? Constant temperature থাকা মানে কি হচ্ছে না? No. A constant temperature circuit means what isn't happening. Yeah, it's not heating up, which means there's no energy loss. And then isn't that what we are looking for? So there's only one way you can achieve that, by the way, just bole rakhi. It's using something called superconductors. So it's only syllabus tonight, shikano hai, orokomo kichu na. It's very complicated physics. Superconductors are materials that conduct electricity with what resistance? Zero, like absolutely zero, right? If they can achieve kora hoy, you have to take them to like next to absolute zero temperature. So when you take it down to absolute zero temperature, right, the molecules that are there, the atoms that are there that obstruct you, right, what are they doing? Nothing. They're stationary, right? And the electrons have what? Like a free flow, right? So superconductors is like the only way you can achieve what we're trying to achieve here. So another way, ohmic conductor, actually, it's just a dream. It never actually happens, okay? So আমাদের যেটা করতে হবে, our syllabus did something nice here. That আগে O levels করছিল. They teach you what happens when temperature does increase. And we select a material that temperature increases drastically. And we use what? Filament lamp. So filament lamp, lamps that have like a metal filament inside it, right? They're banned now. You won't be able to see one. But filament lamp at temperature rise when it's operational temperature key. So filament lamps operational temperature is actually more than the temperature of the surface of our sun. Our surface of the sun temperature is 4,800 Kelvin. Filament lamps can go up to 6,000 Kelvin. Tungsten and the tungsten heats up, right? So you know how much energy it wastes actually. Why is it a waste? Filament lamp into the main energy provided goes to what? Heat. And then residue, when a heater with about this, তখন excess energy কি হিসেবে release করে? Light. And we use that for light. We used to use that for lighting. Can you imagine the how inefficient that process was? 98% of the energy was lost to heat the filament, then baki 2% কি করা হতো? Light each other, right? Thanks to LED, filament lamps are, just not the solution anymore, ever. Okay, LED efficiency is very high. To give you a context, such a simple context, 100-watt filament lamp, right? ওইটা যে power, ওইটা যে brightness provide করে, এইটা কিন্তু হচ্ছে বেশি করে. This square one that you see here. Do you know what power this is? Producing the same amount as that 100-watt. Yeah, it's actually 5 watts. Okay, just 5 watts. The 5-watt LED produces brighter light than 100-watt filament lamp. Obviously, because filament lamp is designed for 100 watt produce light. It's actually a very big watt heater, and they use it as a heater now. So they use it in incubators, patches. They use it in bakeries to keep the stuff warm, right? It's a very good heater. Okay, so yeah, filament lamp So if you look at a graph of filament lamp, you'll notice that it is not going to be a straight line, right? And graph like so will it be increasing at an increasing rate, or what do you think is the shape going to be? Increase in এটা আচ্ছা increasing at a decreasing rate. I mean, if you agree, it's an increasing at a decreasing rate graph. বুঝছো কোনটা? Increasing at a decreasing rate মানে কি? It's that, right? So the correct answer is impossible to tell. I'm Texas DNA. What graph are you labeling? Right? So আমি কেন এটা বললাম তোমরা এক্সাম এটা করে ওরা কি করে আমরা IV শিখতে থাকবো forever, right? And then MCQ will have a what graph? VI graph. Achha, so be careful about the axis. Achha? So yes, of course, traditionally it would be a what graph? IV graph, because what are we normally varying in a circuit to investigate voltage, right? And yes, you are right. It will have a gradient that decreases like this, okay? And the gradient of the graph corresponds to what? 1 by R, right? So you can have a gradient or variation. So yeah, I think last question we can use the gradient, right? Remember, to find resistance. So like the gradient use shouldn't that be incorrect? So there's a catch here. You can't use a gradient to find absolute values of resistance. You can use gradient. I mean, you can use gradient to find what? Trend. Trend মানে বুঝো কি হচ্ছে, চেঞ্জটা কি হচ্ছে. So I won't get the right value from here if I find the gradient, but I'll find the what here though. The trend, মানে বাড়তেছে না কমতেছে, আচ্ছা? And you can clearly see here that the gradient of the graph কমে যাচ্ছে এখানে, and which means that if I do my resistance math, gradient is equal to 1 by R. যেহেতু gradient কমে যাচ্ছে, resistance বেড়ে যাচ্ছে, and that's the graph for filament lamp. Okay, so এটা O level stuff. If you remember, এই একই জিনিস করছিলাম. So A level কি? There must be something new here, right? New হচ্ছে why. Why is the graph like this? Acha? So there are two answers here. একটা হচ্ছে describe the graph, আরেকটা হচ্ছে explain the graph. And এটা O levels একটা বড় problem ছিল. আবার emphasize করি, describe মানে কি? What is happening here? Or explain মানে কি? Why is it happening? So can you describe this graph to me? For 3 marks, describe the graph.
As voltage increases, current increases and decreases.
That's how you put it. Okay, very good. So what you say is, as voltage increases, current increases, right? Voltage about this current, but is it increasing linearly? No, right? So as voltage increases, the current increases at a decreasing rate, right? Which means what is increasing? Resistance. Acha, ওটা বলা লাগে না normally 3 marks এর মধ্যে you just describe what the graph looks like. একটা জিনিস তাও বলে রাখি, most of these graphs প্রথমে দিকে কি করার চেষ্টা করে? Straight line, because what is it trying to obey originally? Ohm's law. But at the point too much current jawate, what does it start to do? Overheat, and that's when it starts to change drastically. Okay, so in some answers you might have to mention the fact that initially, right, voltage and current are directly proportional, but eventually as voltage increases, the current decreases, right, or current increases at a decreasing rate, hence resistance increases. আমি লিখে দেব answerটা. This is the description. এখন আমরা যেটা দেখবো is the why. So screen it to দেখো. Why is the filament lamp's resistance increases as current increases? Again, it's a thing I'll keep on saying in this electricity chapter. You have done this in your O levels, okay? Because it is what it is. O levels করে আসছো তোমরা এগুলা. So কেউ কি আমাকে রিমাইন্ডার দিতে পারবা যে why is the resistance of the filament lamp increasing as the current increases? It's a 4-mark answer. Potentially 5 ও করা যায় যদি চাও, but কেউ কি বলতে পারো reason?
Current to pass through the particles harder.
Current to pass through the particles harder. Yeah, I mean, in summary, you're right. So essentially, যেটা হচ্ছে, I'll start from scratch একদম, মানে let's say circuit এখনো on হয় নাই. Okay, do you know what these are? Yeah, these are called positive lattice ions. Acha, protons na. Positive lattice ions. They're the core of your metal. Acha, so metal is a nucleus gulo. And around them, what do you have? The sea of what? Yeah, delocalized electrons. So you have billions of these delocalized electrons out there floating around in and around this metal. So I have a question, a very elementary question, something that lower class জিজ্ঞেস করা উচিত ছিল, বাট এ লেভেলসে এমসিকিউ তে আসে। Are these electrons stationary or are they moving? Delocalized electrons are moving. Yeah, no current is flowing. Are these electrons stationary or are they moving? They're moving. They're moving a lot. Okay, it's a sea, and sea has water. Water is stationary or moving? Moving, right? It's just like that. Tell me, why is there no current here? Isn't current the rate of flow of charges? So, very good, right? There's no net flow. There are 10 going left, there are 10 going right, there are 10 going up, there are 10 going down. So they're all moving, but they're not moving which way? In the same direction. Once you provide like a plus and a minus, which way do they all move? Same direction. And that's when you have a current. Okay, so metal thermodynamics, there's always movement of charges, but what's not there is net flow. Okay, so anyways, আমরা যখন power supply on করব তখন কি হয় দেখি। So once we turn on the power supply, you have your electrons here, and they're moving from the battery, মানে battery থেকে move করতেছে carrying what? Energy, charge and energy, mainly energy, right? একটা সার্কিটে কিন্তু functional property যেটা we rely on is not the charge, it's the what? Energy. A circuit is nothing but an energy providing setup. আর কিছু না কিন্তু। So this charge is moving like this, carrying energy from the battery, and then it collides here. Once it collides with positive ion, right, what does it transfer a little bit to the positive ion? Energy. ও নিজে কিছু energy lose করে, right? So a positive ion is now a little warmer than before because it has extra energy than before, right? So এরকম করে করে, and I think I might have mentioned যে ভিতরে যখন যেতে থাকে, remember the drift velocity thing? What does it start to do? Collide here, there. And as it does that, a lot of these particles that it collided with, right, will gain energy. And as they gain energy, they won't be just, as they are. They'll start to do something. What is it? No. Vibrate na ki heat up. Acha na, vibrate na. They'll start to vibrate more. They're always vibrating. Achha, so if you say they start to vibrate, that means that you were at absolute zero, right? But no, they're at normal temperature. So what will they start to do? Vibrate more vigorously than before. And as they start to vibrate more vigorously than before, the subsequent, this is important, poorer electrons will feel what time to pass through, a difficult time to pass through. So current কিন্তু প্রথমে বাড়াতে হবে for this effect to start. শুরু থেকে হয় না। That's why শুরুতে গ্রাফটা কি হতে পারে? Straight line. আচ্ছা, তারপরে কিন্তু eventually হয়, because what does the material need to do in order for this to happen? Heat up করতে the inner time দিতে হবে, right? So yeah, as the energy starts building up, right, these particles provide more resistance and obstruction to the flow of your charges, and as a consequence, the electrons are flowing at the same speed as before or less than before? Less, right? তার জন্য কি বেড়ে যায়? Resistance বেড়ে যায়. That's an O-level answer. Acha, A-level, so we can't use this answer. We have something better. I'll teach you that. So A-level se ki use korbe dekho. Ja bolchi shob thakbe. Just last say, you need to bring back something I told you you'll have to use here. The what equation? Transport equation. So transport equation mone ache? What was it? N A Q V. Amra ekta wire use kortechi, so Q tar jagay ki ashbe? Electron charge, and V is going to be your what? Drift velocity, right? Now tell me, okay, ekhane ki hocche? N is what again? Number of charge? No. Sorry? Charge carrier density, right? What is it? Yeah, number of free flowing charges per unit volume. Okay, so this is charge carrier density. Charge carrier ta hocche ekta value. This is not that. This is per unit volume. So charge carrier density. Tarpor eta ki? Cross sectional area of your wire. Eta hocche charge, and vita ki? Volume. So the volume, drift velocity, right? Average drift velocity. And what is I? The current in the circuit. And here's my question for you, right? As the material heats up, listen very carefully. As the material heats up, right? N ki bare common or same thake? Same. It's the same material, right? Why would N change, right? So N constant. Cross sectional area ki bare common or same thake? Here's the thing. It might expand because of heat, right? But I'm assume kori ki that change is very negligible. Okay, so cross sectional area এরকম বাড়তেছে না, charge change হচ্ছে না, drift velocity কি বাড়বে কমবে না same থাকবে? drift velocity? Drift velocity is the average velocity that the electrons take to pass through, right? ওটা কি বেড়ে যাবে না কমে যাবে না সেম থাকবে? কমবে, very good. কেন? because হচ্ছে aren't they facing more obstruction? So যদি current যে drift velocity কমে যায় তাহলে current কি হবে? কমবে। আর current কমা means materialটার resistance কি হয়ে গেছে? বেড়ে গেছে। That is how you answer. Okay, so এখন থেকে answer করতে হলে you have to use the transport equation in your answers. There's no alternate to it. Okay, so you say that so how do you, I mean, answer the but how do you phrase it? So you say that as the current voltage increases, current increases, there's more number of collision, and that causes the positive ions to gain energy, and as they gain energy they start to vibrate more, and as they start to vibrate more, the average watt of the electrons decrease, drift velocity, because they find a difficult time to pass through due to more obstruction. As the average drift velocity decreases and everything else remains constant, what happens to the current now? Decreases, which means what increases? Resistance. একটা কনফিউশন থাকে স্টুডেন্টদের যে কারেন্ট কমে যাচ্ছে নাকি কারেন্টের বাড়াটা কমে যাচ্ছে, কি মনে করো? কারেন্টটা কমে নাকি কারেন্টের বাড়াটা কমে? বাড়াটা কমে। আমি বলি কি হয়, তুমি যখন হচ্ছিল 5 ভোল্টস বাড়াচ্ছ প্রিভিয়াসলি, কারেন্ট বাড়তো 5 অ্যাম্পিয়ার্স। এখন 5 ভোল্টস এর জন্য কারেন্টটা বেশি বাড়বে না, একটু কম বাড়বে। কেন? বিকজ নাও ইটস মোর অবস্ট্রাকটিভ। সো ভোল্টেজ বাড়লে কারেন্ট কিন্তু বাড়বেই, বাট এখন কি বাড়বে? কম বাড়বে। এন্ড দ্যাটস a representation of an increase in what in your circuit? Resistance. Okay, so yeah, that is the filament lamp. আমি এটা নোটস দিয়ে দিচ্ছি, but I want to do all of them and then I'll give you the notes, okay? Because to wrap up what you say. Does the velocity of the electron depends on the energy it carries? No, velocity of the electron depends on these things. I-N-A-E, Arkishna. So it depends on the current, it depends on the charge carrier density, it depends on the cross-sectional area and the charge itself. হ্যাঁ, তোমাদের মার্ক স্কিম গুলো আপলোড করবো, ওটা বাকি আছে। I uploaded a waves file আজকে, okay? Metal atoms vibrate more, restricts movement. আচ্ছা, okay, ঠিক আছে। Let's see something interesting now. সবাই হচ্ছে একটু দেখো এদিকে, we need to see the graph for a thermistor. So এখানে হচ্ছে তোমাদের সিলেবাসের মধ্যে you have, আমি জাস্ট একটু দেখেন কি কি লাগবে। IV characteristic of a metal conductor at constant temperature, that's ohmic conductor, a semiconducting diode, আমি দেখাচ্ছি এটা in a bit, a filament lamp. But আমি যেটা করছি right now is this: explain the resistance of filament lamp increases as current increases because temperature increases. Understand the resistance of a light dependent resistor decreases as light intensity increases. Understand the resistance of a thermistor decreases as temperature increases. So এই লাস্টেরটা খুব ইম্পর্টেন্ট, নাম্বার 8 যেটা। থার্মিস্টর কেন হচ্ছে রেজিস্ট্যান্স কমায় দেয় টেম্পারেচার বাড়লে? So that's something we'll have to look into. Okay, so let's see this. You guys know what a thermistor is, right? Thermistor is an electrical component যেখানে টেম্পারেচার বাড়লে রেজিস্ট্যান্স কি হয়? কমে যায়, right? So তোমাদের হচ্ছে look what happens. কেন এটা হয়? Now finally maybe you'll understand. As O level say, we only needed to know what happened, not why. So it's an IV graph for a thermistor, and the graph looks like this. The temperature, voltage বাড়াচ্ছ, current বাড়াচ্ছ, temperature বাড়তেছে, and resistance টা কমে যাচ্ছে, এরকম দেখতে হয়। So এখানে gradient কি করা হচ্ছে? বেড়ে যাচ্ছে, which means resistance কি হচ্ছে? কমে যাচ্ছে, right? বুঝছো? But why? আচ্ছা, so let's see. এখানে কোনো ডায়াগ্রাম কিছু ড্র করা নেই, clearly শুনো কি বলি আমি। So transport equation one more time. I equals to NaEV. And এটা দিয়ে আমাকে এক্সপ্লেন করতে হবে কেন টেম্পারেচার বাড়লে তোমার হচ্ছে রেজিস্ট্যান্স হচ্ছে কমে যায়। So এটার জন্য I'll have to take a little bit of detour, unfortunately. তোমাদের সিলেবাসের মধ্যে এটা ভালো করে এক্সপ্লেন করার স্কোপটা দেয় না। So I'll show you কি হয় এখানে। So it's called band theory. কারো কি স্কুলে করাইছে band theory? Band theory? No? আচ্ছা। What is band theory? It's something that will help you understand materials better. So what's band theory? So band theory tells you that when you have an atom, right? Atomer mode, there are different types of bands out there. Bands মানে হচ্ছে energy bands, by the way. And these bands are based on the location of the electrons. Let me explain. So যে ব্যান্ডটা আমি এখন ড্র করতেছি এটা তোমরা খুবই familiar. You have heard about this many times. This is called the valence band. So what's a valence band? A valence band is the place where you find your what electrons? Valence electrons, obviously, right? But band can বলা হয়. If you learn ionization energy, you'll learn that the electrons are found at discrete energy levels. It's very specific location, right? So band can এটা. So this one actually comes from this idea that when you have a nucleus of an atom and you have your shells here, যেখানে electrons গুলো থাকবে. So that's one location of a shell, right? And then you have another shell here. That's another location of a shell, right? তোমরা কি জানো metallic bonding কি? Metallic bonding is when your ions are so closely packed, right? ওদের electrons গুলো কি decide করে? That they'll leave. Do you know that? No? How is metallic bonding formed? Don't you have that in chemistry anymore? আছে? আচ্ছা আমি basic idea বলি. Let's say you don't have chemistry. What's metallic bonding তাহলে? So you have an atom here. এই যে পাশে আরেকটা atom আনলাম. This atom is যে positive যে partটা that's very closely packed because it's solid, right? আবার আমি আরেকটা আনলাম এখানে very closely packed, right? আরেকটা আনলাম মানে 3 dimension imagine করো সামনে পিছে মিলে. As I keep stacking them up একটু side এ মানে সব হচ্ছে কিন্তু হচ্ছে exact location এ না. You'll start to notice that the shells are no more a particular line. They're a particular what? Band. এই যে দেখো shell গুলো কি একটা region create করে ফেলছেন ওরা. And why did they create a region? Because every single atom is slightly off from the other. তাহলে ওদের electrons গুলো slightly পাশে থাকবে. So if you keep stacking them up, এই যে আমি যদি stack করতে থাকি, I add more of these, right? এখন যদি তোমাকে কাউকে জিজ্ঞেস করা হয় যে what is this, right? এখানে যে electron গুলো এগুলো সব valence shells কিন্তু, right? Would you say it's a single orbit or will you think it's like a band? It looks like a band, right? Why is that? So because the positive ions are so closely packed, right? Or their electrons below just slightly edik odik hote thake. So once you have a billion of them, that energy valence shell is like a band out there. Okay? So it's called a valence band. Here you'll find what? All the valence electrons. Okay? Now the problem is valence electrons don't help in conduction. And I'll tell you a reason behind this. Non-metals, right? Do they have valence electrons? Yes. Non-metals have more valence electrons than some metals out there. But your non-metals don't conduct. Can we? That is because there is a region where your valence electrons need to be. So there's a region where your valence electrons need to be in order for them to be able to conduct. It's called the conduction band. It's a separate location. It's like they are part of the conduction system. Non-metals a key problem. Non-metals the gap between your valence band and your conduction band is very large. So you can't make your electrons go there. They never go there. So as a result, non-metals never conduct, right? So this diagram I've drawn here is what you expect in a non-metal. How does this look like in a metal? So metal কি সবসময় conduct করে নাকি মাঝে মাঝে conduct করে? some metal properties and some non-metal properties. Acha, okay. Little different. I'm saying and maybe chemistry wise chinta korle yes, because of the +4 and the -4, it can act as a metal and a non-metal, give ions, take ions, right? But physics the approach is a little different. Okay, so physics is more towards the property of the material. Interesting. Right. So back quick to the so what I was trying to say is that you have your conduction band here and you have your valence band there, right? So আমার যদি হচ্ছে এই conduction bandটা আর এই valence bandটা যদি overlap করে, aren't there these electrons there that are always conducting? Do you understand what I'm trying to say? Acha, okay. So this is the diagram for what? A metal. This is the diagram for what? Non-metal. Because কোনোদিন কিছু হবে না. There's no possibility. We are looking for semi-metals. And semi-metals se jeta hoy, very important, listen carefully. The bands are really close, like that. Okay? And that gap that you see there is achievable through what? Heating them or providing them energy. So once you provide a semi-metal energy or you provide them heat, right? কি হয় valence electrons গুলো jump করে উপরে উঠে যায়, and now they're at which level? Conduction. And what do they start to do? Conduct. Temperature কমায় দাও, they'll again fall back to their normal state, and what does it become again? An insulator. Semi-metals are actually materials that become perfect metals and then suddenly become perfect non-metals based on the conditions you provide to them. They're not like some metal properties, some non-metal properties. They're all metal properties at one stage, and then all what properties at one stage? Non-metal, right? So আমাদের thermistor is a what? Semiconductor. So আমরা যখন thermistor normally buy, like room temperature, it looks something like this. Where is it conducting? No. The moment you start to provide energy to it, the electrons have capacity to move up, and as they move up, they start to become what? Conductors. And suddenly your semiconductor, which was an insulator before, has now become what? A conductor. And conductor to the hoy, can you tell me in the equation I equals to NaQV, right? Which quantity is supposed to change? মানে আমার যদি ইনসুলেটর থেকে কন্ডাক্টর হয়, রাইট, এই ইকুয়েশনের মধ্যে কি চেঞ্জ হওয়ার চান্স থাকতে পারে? Yes, n. Semiconductors এর সবচেয়ে বড় জিনিস হচ্ছে টেম্পারেচার রাইজ হলে n rises, and n rises drastically. Every single atom releases what? Electrons. Can you imagine the number of electrons are released as a process, right? A change হয় না, E change হয় না. Drift velocity বাড়ে না কমে when you increase temperature? Drift velocity কমে, এখানে কিন্তু কমে, but it is offsetted by a drastic increase in what though? And so gradually and eventually, what will be the bigger change in your material? And so current ki barbe na kombe as a consequence? Barbe. And that's the reason why semiconductors ke jokhon heat kora hoy, they become a good conductor. Why? Because they release plenty of what into the system? Electrons. N bere jay. Buchho jinishta? That's the reason behind it. So semiconductors are behavior rated. That's why thermistor temperature barle ki hoy, resistance kome jay. Now let's come to LDR. Do you know what an LDR is? By dependent resistor. It also does something similar. Light intensity barle ki kome jay. Can you tell me what the light triggers? Yes. Okay. So আমাদের thermistor heat triggers the band, and heat দিলে bandটা rise করে. LDR কি place করলে হচ্ছে band গুলো rise করবে? Light. So when the light falls onto your metal or semi-metal, right, the light causes the electrons to rise up, and again what increases? N increases, and what decreases? V decreases, and overall what increases? I. Acha. So yeah, that's the logic behind each of them. A band theory not part of our AS syllabus. It used to be there in A2 or A2 think about these, okay, which is very unfortunate, as I feel je eta de jinish gulo buchhano ar easier hoy. Anyways, which one? What I just said. Oh, the circa dumbed down version. Oh, there's a lot of things going on here about how bands interact with each other.
Has it been proven?
Yeah, that's what's a theory.
But theory means it hasn't been proven yet.
Ah.
That's it.
Oh. Okay, so this is your insulator. Insulator. This is your metal.
We need to know that
Can jump for it. ওটা তো you learn in A2 তে শিখবা physics, but chemistry তো আছে তো the excitation of electrons when you provide energy to them. Physics এ লাগবে, but ওটা different ভাবে লাগবে. We have a chapter called quantum mechanics, so এখানে লাগবে.
Sir.
Yes.
Can we make an insulator act like a semi-metal or metal by heating it?
The problem is, yes, you could, but once you start to provide heat to them, the insulator will start to heat up so much, it changes state before the electrons can rise up. And that's the reason why you'll never get that stage where the electrons actually go up. It just becomes a liquid. For example, sodium chloride crystals, they are insulated. But if you keep heating them, not solution, sodium chloride solid crystal, right? If you keep heating them, at one point they start to conduct. When it becomes what? Molten sodium chloride, right? So মাঝখানে electrons গুলো jump করার scope পায় না, ওটার আগে sodium chloride melt হয়ে যায়. Right, so আমি হচ্ছে নোটটা দিয়ে দিচ্ছি, তোমরা আগে এটা কপি করে নাও, the one for filament lamp. Why doesn't, that's a good question. Why doesn't the current decrease even though the eta decreases, drip velocity decreases? কেউ বলতে পারবে reason? Current কেন কমে না drip velocity কমার পরেও? Yeah, the increase in n is like 1,000 folds greater. Do you understand what I mean by that? It's like multitude times greater. Our velocity decreases like, half হচ্ছে, আর ওটা বাড়তেছে 1,000 times. So, it can't compete with that change. So we are done with resistors. আমাদের এই answerটা একটু copy করে নাও. And now in the next class হচ্ছে I'll be starting the circuits, Kirchhoff's laws. Right, this is the standard answer. Are you guys solving question papers? Have you started them? It's already beyond the point of no return. আচ্ছা মানে এখন যদি শুরু না করে থাকো, you're already behind, and I don't know how you can catch up. Okay, so just make sure you have started. MCQ হচ্ছে as many as you can. I'll tell you reason behind that. MCQ হচ্ছে repeat হয়. Every MCQ that comes in every year, right? We can at least 20%, মানে হচ্ছে 10 questions হচ্ছে repeat. Like, option shall repeat, like perfect repeat. So the more you do, there's a incentive in getting things home. Our structured paper যেটা, ওটা I feel like হচ্ছে 17 onwards করে better. 17 থেকে এখন পর্যন্ত because syllabus অনেক চেঞ্জ হচ্ছে তো মাঝখানে, so অনেক সময় ম্যাচ করবে না, বাট এমসিকিউ যত বারবার করবে.
Last year, last, I don't know.
I mean 20 years আগে থেকে আছে so that's the thing if you want to get common ones you have to do as many as possible but আসবে I am always sure যে there's always a repeat yes and if you want a surprise in the exam করো না এগুলো you know just be prepared for anything that's possible
What is the lack of questions?
না I think হচ্ছে ওরা একটা এটা করে এই স্যাম্পল টেস্টিং মানে একটা এমসিকিউ অনেক আগে দিছিল and student did very bad and then they give that again to see if there's an improvement or not
It's a disappointment. Who actually checks our papers? Students or professors?
non-professionals non-professionals
Why?
they're not related to the education industry
Isn't it?
no you can there are sites where you can go and find them hiring people to check paper qualification key it should be able to read English that's it
Anyway, that's possible.
that's it
Asian labor English and validation.
ওরা তো অটোমেট করার চেষ্টা করতেছে পারতেছে না সো ইভেন্চুয়ালি হয়ে যাবে না মানে তোমাদের এক্সাম গুলো ইভেন্চুয়ালি অন স্ক্রিন হবে অলরেডি স্টার্টেড ফ্রম দিস ইয়ার আই থিংক 6টা পেপার হচ্ছে অন স্ক্রিন হয়
So they're going to supply assignments.
না তোমরা একটা কম্পিউটার ল্যাবে বসে কাজ করবে
It's too weird.
কেন এসএটিএস জিআরই তো এভাবে হয়
Even worse.
হ্যাঁ হ্যাঁ পাকিস্তানের সবচেয়ে বেশি শ্রীলঙ্কাতে আগে অনেক বেশি ছিল এখন কম বাট পাকিস্তান সবচেয়ে বেশি মানে ফ্রিল্যান্সার যারা থাকে ওদেরকে হায়ার করে পাকিস্তান নাম্বার 1 ফ্রিল্যান্স hired I think so yeah. Bangla people to definitely Bangladeshi check করতে হবে আর who's going to take it আচ্ছা হ্যাঁ
So what about the papers? Difficult to ask.
papers there's a YouTube video on it খুবই high security তে আছে
UK থেকে প্রিন্ট হয়ে আসে
হ্যাঁ ওরা সিল কন্টেইনার্স আসে এন্ড ওগুলা সিল যদি ব্রোকেন থাকে তাহলে এক্সাম ক্যান্সেল হয়ে যায় তাই
Seeing the paper.
ও
You know, paper wraps.
Yes, I tried.
We are opening.
না বাট these are all printed UK তে তারপর পাঠায় UK তে প্যাক করে
ছবি তোলার মাধ্যমে।
না ওরা UK তে পাঠায় তারপর UK তে there's this very large factory মতন জায়গা ওখানে পেপারস গুলো হচ্ছে just একটা বক্সে রাখে it's fully automated scan হয়ে যায় তারপর they send it to all the examiners
Is it same for both pages and
yeah the paper checking is done not by Excel Cambridge it's a third party company called Result Plus ওরা এই জিনিসটা করে তো ওরা এই লোকগুলোকে হায়ার করে অনলাইন
So but the execution is checked by the machine.
yeah ওটা বোঝানো হয় তো ওইটার বাইরে কিছু আর পারে না
MCQ গুলা machine check করে।
হ্যাঁ এমসিকিউস তো এই যে পেন্সিলে যেতে ওএমআর পেপার আছে ওইটা একটা পেপার দিলে চলে আসে মার্ক Don't the charges lose drift velocity when they initially collide with the ions? Yes, they do. So that is the reason why it's a slow velocity to begin with. But with the increase in temperature, it gets slower. Do you guys get to see your paper after the exam? edX এ যেমন মেইলে চলে আসে তোমাদের দেন না?
So we have to pay next week or something.
No, আচ্ছা।
Well, okay. for one single paper.
To see your paper. Edexcel paper check করলে you can see it's horrible. It's very poorly checked. Like mark schema answer to word এখানে লেখা 0. And then you send for recheck. Recheck এ তোমার যদি grade বাড়ে then you get a refund. Otherwise টাকা রেখে দেবে ওরা। And ওরা কোনোভাবে grade বাড়াবে না। So ওরা কি করে ওইখানে মার্ক দিয়ে দিবে আর এক জায়গায় কেটে ফেলবে, which is also unfair by the way. আর তুমি কি আবার recheck এ পাঠাবা, ওই অপশন তো নাই। So eventually ওর কিছুই হচ্ছে না। Non-profit. That's what they call them. So that's some mean. Charity. But Edexcel is a university partner, Oxford University. না AQA, OCR, Edexcel সবই হচ্ছে অক্সফোর্ডের। না কেমব্রিজ আরও আছে। We should start a board, like a breakaway board. MSG board. No, it's false. I know what it is. It's not that. That's not a person.